if you want to take a vacation, take it before that date, because who knows what will.
Imagine a visitor from deep space so precise, so unnatural, it makes scientists question whether it's even obeying physics at all. 3I Atlas isn't just another interstellar rock, it's a cosmic anomaly, rewriting every rule we thought governed the motion of the stars.
The deep void holding its secrets close, but this time something broke that cosmic silence. A relic from beyond, 7 billion years in the making, tore into our solar neighborhood. Our next story telling you how the celestial visitor has rewritten the physics textbook in a way, and then in a way disappeared from the script.
It begins like a trick of chance, a streak of light cutting through the void, gliding with uncanny perfection across the solar plane. But the deeper astronomers look, the more impossible it seems most interstellar visitors enter recklessly. They dive in at wild angles, scattering like dice thrown by the galaxy itself. But alas, it doesn't. It moves with the elegance of design. Its path slices through the ecliptic plane, the thin, flat highway our planets follow around the sun, tilted by only 5 degrees. It aligns itself in 1,000,000,000 to 1 alignment. This alignment is a precise mathematical calculation. To move like this from interstellar space isn't luck, it's precision, like tossing a grain of sand across a stadium and watching it land perfectly in the groove of a record. Still, Atlas does more. It swims against the flow, retrograde motion, defying the natural direction of planetary traffic, but never drifting from its lane. Astronomers run the numbers repeatedly. The odds remain impossible. Simulations show thousands, even millions, of potential interstellar paths, and none reproduce Atlas's course. It's like the cosmos itself aimed and fired. Some call it a coincidence. Others whisper a darker thought. What if something, or someone, wanted it to move this way? The ecliptic path, the retrograde precision, the flawless velocity. Every detail feels intentional. A silent traveler crossing our celestial highway with the grace of an engineered orbit. In observatories across the world, scientists stare at their monitors in disbelief. Whatever Atlas is, it isn't playing by nature's rules. Then comes the second riddle, the weight of the impossible. When Atlas first appeared, its brilliance was stunning. Astronomers measured its reflected light, expecting to estimate a predictable mass. The numbers came back monstrous, 33 billion tons. Heavy enough to tug at nearby planets, massive sufficient to warp orbits, rattle sensors on Mars. But Mars never flinched. Neither did its orbiters. Not a single wobble in any trajectory. A comet that big should leave fingerprints across the solar system. But Atlas moves through space like a phantom. Its mass says mountain, yet its gravity says nothing. It shines like iron but acts like smoke. To scientists, that paradox is maddening. Some propose that Atlas isn't solid at all, but a hollow lattice, a web of cosmic foam so delicate that gravity barely recognizes it. A structure that looks vast, yet weighs next to nothing. Imagine lifting a boulder that floats like a balloon. That's Atlas, a ghost masquerading as a giant. Others suggest something stranger, a shell of reflective dust or metallic vapor designed, yes, designed, to mimic mass while hiding its true nature. A decoy body drifting through sunlight, fooling every calculation. The data refuses to settle. Instruments detect brightness, but do not pull. Volume, but not weight. By every measure, Atlas should be heavy enough to bend the space around it. Instead, it glides untouched, an illusion of substance, a cosmic mirage. For scientists, it's no longer just a comet, it's a question mark carved into heaven. If something can shine like a mountain and fall like a feather, what else in our universe have we been misunderstanding all along? Every comet dances to the same ancient rhythm. The closer it drifts toward the sun, the more the heat sculpts its tail, always pointing away, a bright streamer carried by solar wind. It's one of the simplest cosmic laws, but Atlas breaks it. When its tail ignited, astronomers watched in disbelief. One jet, thin, fierce, deliberate, didn't flee the sun. It fired straight toward it, a rebellion against physics itself. Solar models predicted chaos. The sun's radiation should have scattered the particles outward. Instead, the jet held formation, burning forward with surgical precision, as if propelled by intention. What could make a comet aim into the very force that should destroy it? Some theorized an ultra-dense patch of compact dust, focusing energy like a cosmic lens. Others blamed a chemical imbalance. Data revealed Atlas's vapor composition was bizarre. Carbon dioxide levels were 8 times higher than water vapor. A comet is practically exhaling pure CO2, behaving more like an industrial reactor than an icy rock. Still, the pattern of that forward jet nagged at researchers. It wasn't random. It pulsed in intervals, steady, rhythmic, almost mechanical. Natural outburst? Maybe, or something else. In the silence of deep space, Atlas seemed to be aiming. Each pulse is a heartbeat. Each flare is a message. What if the jet wasn't a reaction, but a response? Then the discovery that shook the entire scientific community. Spectrometers analyzing Atlas's emissions returned a line signature so bizarre, researchers thought it was an equipment glitch, but it wasn't. Amid its gaseous plume, Atlas was releasing nickel tetracarbonyl, NiCO4, a compound that, on Earth, doesn't occur naturally. It's an industrial chemical, lethal to humans, used in metal refining and plating. To produce it, you need intense pressure, carbon monoxide, in controlled conditions that simply do not exist on a comet. Yet there it was, pouring from an object drifting between stars. At first, skeptics called it contamination. Maybe Earth's atmosphere, maybe sensor interference. But multiple telescopes across continents confirmed the same spectral fingerprint. No errors, no noise, just raw metallic truth. Nickel tetracarbonyl is a gas that bonds with metal surfaces and is used to purify alloys in factories. It breaks down under sunlight, making its presence around Atlas even stranger. It shouldn't survive long enough to be detected, and yet it persisted. Scientists scrambled for natural explanations. Perhaps nickel sublimating from the core, reacting with trapped carbon monoxide under unknown pressures, but calculations failed. Temperatures too low, energy too weak. No natural process could explain such chemical precision. The debate turned philosophical. Was this a chemical coincidence, or the universe's first techno-signature? Evidence of artificial chemistry in deep space. If Atlas is natural, it's rewriting chemistry itself. If it's not, then something out there is refining metal, miles from any sun, in the dark between the stars. And for the first time, humanity stares at a comet not as a rock or a relic, but as a machine. Late October 2025. Something extraordinary happens. Atlas, once pale white with faint golden trails, suddenly ignites into a deep electric blue. NASA's Stereo A, the Soho Observatory, and Japan's GO-19 probe all capture it. Every frame glowing brighter, purer, and almost unnatural. First, scientists assumed a typical spectral shift. Many comets emit faint blue when cyanogen or ammonia gases react with sunlight. But this wasn't faint. This was blinding, a sapphire beacon blazing across the void. Spectral data confirms cyanogen and ammonia. Yes, but the intensity breaks the scale. Ratios skyrocket far beyond what physics predicts. No known reaction can produce such vivid luminosity without massive energy input. Some theorize internal crystallization, a cascade of buried ices erupting from within others, whisper of a deeper transformation, a change in its very chemistry as it nears the sun. But the most chilling observation is its timing. The blue shift begins precisely as Atlas enters its solar blackout window, as if the object is preparing, a color born of poison and flame, a transformation no comet should survive. Atlas isn't just reflecting light, it's becoming light. The moment those blue images hit the web, Earth's scientific community ignites. From Chile's Atacama Desert to Hawaii's Mauna Kea, from Europe's VLT to India's IUCAA, telescopes lock onto Atlas. Data floods in. Every wavelength, every frame, every anomaly scrutinized. But the interpretations collide like storms. Some call it the ghost comet, a mirage of physics, a structure of near-zero density. Others claim cosmic foam is the first evidence of matter existing between solid and gas. And then there are the radicals, the ones whispering alien engineering. Social media erupts, hashtags trend globally, YouTubers, journalists, skeptics, and dreamers, all drawn into the spectacle. Every nation, every language asks the same question. What is Atlas? For a moment, humanity unites in wonder. In labs, in classrooms, in living rooms, eyes turn skyward. Scientists who've never spoken before exchange raw data at 3 a.m., translating math into hope. Atlas becomes more than a comet. It's a mirror, reflecting not just sunlight, but our insatiable need to understand the unknown. For the first time in years, science feels like a shared heartbeat, and that heartbeat races. Then, silence. From October 22nd to November 7th, Atlas vanishes behind the sun. The perfect alignment is called a superior conjunction. No telescope dares look. Solar safety protocols forbid it. The sun's glare can burn sensors, blind instruments, and destroy billion-dollar observatories in seconds. Even Hubble, even James Webb, helpless. The blackout arrives at the worst possible moment. Atlas is now at its closest approach, its fastest velocity, and its most mysterious phase. Whatever happens there, eruption, disintegration, maneuver, goes unseen. NASA's Deep Space Network logs no radio echoes, no reflections, only silence. Scientists go into forensic mode. They build models, predict outcomes, track gravitational fields for microscopic changes that might betray Atlas's fate. But there's a tension no math can ease. If the Atlas fragments, debris patterns will tell the story. But if its path shifts, if it steers, then humanity will face a question it has never been ready to ask. In those hidden days, as Atlas orbits unseen behind the sun, observatories wait like detectives outside a closed door. The cosmos is silent, the instruments are idle, and somewhere in that blinding light, an object that breaks every rule may be rewriting them all. While Atlas hides behind the sun, Earth's brightest minds don't rest. Supercomputers run parallel simulations, two futures racing side by side. Scenario 1, a natural breakup. Solar radiation penetrates deep into Atlas's fragile core. Internal pressure builds until the nucleus bursts apart, scattering fragments in predictable arcs. Scenario 2, controlled deceleration. A deliberate reduction in speed, 20 kilometers per second, precise enough to suggest intention. If that happens, it wouldn't be a comet anymore. It would be a maneuver. Teams from NASA, ESA, and JAXA coordinate with military radar networks, searching for any electromagnetic trace. Even defense satellites are briefly repurposed to catch the faintest blip. The data feeds show nothing, just static. Yet even silence can mean something. Across labs and control rooms, coffee cups go cold. Every second behind the sun stretches into an eternity, because when Atlas reemerges, one number, the change in its trajectory, will decide everything. If it slows, if it turns, if it does anything nature can't explain, then the universe just got complicated. The world holds its breath. After 2 long, silent weeks behind the sun, 3i Atlas is about to step back into view. The glare fades. Telescopes from Chile to Hawaii, from Arizona to the Canary Islands, tilt upward, ready for the moment of truth. For scientists, this is no ordinary observation. It's a verdict on everything we've speculated, feared, and hoped. The first data they'll chase, trajectory residuals. Has Atlas's path shifted by even the tiniest fraction of a degree? The difference between nature and intention could be as thin as a hair. If its velocity or curve shows any deviation, a deliberate deceleration or correction, then something other than physics is guiding it. Next, spectral fingerprints. Instruments will scan for that impossible signature, nickel tetracarbonyl. If it's still there, persisting despite sunlight and space, then Atlas is synthesizing it actively. That alone would defy chemistry as we know it, implying not a frozen relic, but an evolving reactor. And then comes light patterns. Will Atlas return as one body or many? If fragments appear in ordered formations, spaced evenly, moving in tandem, that would hint at intention, not destruction. Nature creates chaos. Engineering creates patterns. Each pixel, each photon will matter. In control rooms worldwide, code compiles. Algorithms sharpen, astronomers wait in silence. Every second of reappearance could rewrite textbooks, redefine natural, and redraw the boundaries of the possible. Because when Atlas breaks free from behind the sun, the universe will give its answer. We'll either witness the quiet death of a cosmic wanderer or the first awakening of something we were never meant to see. In the end, Atlas is more than a celestial anomaly. It's a mirror reflecting our deepest questions about existence itself. If the object is natural, it represents a frontier we never imagined. A new class of interstellar chemistry capable of producing compounds and behaviors beyond Earth's known physics, a living laboratory drifting between the stars, showing that nature can engineer with precision that rivals intelligence. It forces scientists to rethink how elements combine under pressureless voids, how dust and ice can mimic machines, and how the line between chaos and design may not be as clear as we once thought. But if Atlas is not natural, if even a fraction of its behavior hints at control or construction, then humanity is standing at the edge of its greatest revelation. It would mean that intelligence has mastered the art of interstellar travel, not through ships, but through instruments disguised as nature itself. Perhaps probes camouflaged as comets, seeds of technology scattered across systems to observe, to learn, or to communicate without being seen. Either way, the implications are profound. Atlas teaches humility. It shows that even with our most advanced observatories, there are forces and patterns that still slip through the cracks of our understanding. It reminds us that science is not a collection of answers. It's a language of questions. And some questions, like Atlas, travel across light years before we even learn how to ask them. So whether it's a marvel of chemistry or a messenger of intention, Atlas changes everything. It proves that the universe isn't a silent place. It's an ongoing conversation, and maybe, just maybe, we finally heard one of its more curious whispers. Whether Atlas is a miracle of nature or a whisper from intelligence beyond, it reminds us that the universe never runs out of surprises. Behind every comet's tail lies another mystery waiting to ignite. And somewhere, even now, another Atlas may already be on its way.